let's go ahead and take a look at 8.2.7. We're now looking at sampling distributions of proportions right here, and that's a p hat instead of an x bar. And we had certain conditions. In order to solve these probability problems that we have, we need to make sure that the distribution of the proportions, right, not means, but proportions, are normal. Then we can use the normal calculator if they are. And so in this case here, we have some rules here from our notes that I want to remind you of. When we take a simple random sample of size n from a population proportion, right, the shape of the sampling distribution p hat is approximately normal if this is true. The sample size times p times 1 minus p is greater than 10. And again, p is the population proportion. The mean of that, the distribution of the p proportions is equal to p, similar to that the mean was equal to the population mean. The distribution of the means is equal to the population mean. Here, the mean of the proportions of the distributions is equal to the population proportion. And then the standard deviation of those sampling distributions of the proportions is called the standard error, or adjusted standard deviation, and has a formula here, square root of p, 1 minus p divided by n, square root of that. And then in case of when we're looking at, we must also see the model of the previous slide, which is up here, requires that the sampled values are independent. And when sampling from finite populations, this assumption is verified by checking that the sample size n is no more than 5%. So that's a condition for allowing us to conclude that the values are independent. And so to answer this question here, looking at the answer here, describe the sampling distribution of p hat. Assume the population is 3,000. Your sample 600 and your population proportion is 0.4. What is the sampling distribution if you take samples from this population? One, we got to verify that the distribution is normal. N times p times 1 minus p equals 144. It's greater than 10. And once we have that, we also know that the sample size, 5% of the population, is 1,500. Our sample is less than 5%, which is this other condition over here. And then because that is true there, we can then calculate we know that the mean of the proportion is 0.4, which is just p, and then the standard error for the proportions of the distribution is right here at 0.02.